So now my spreadsheet contains the nominal price for a pound of lemons and the CPI for every month from 1980 up to 2012. We're going to need to use a proportion to adjust for inflation to find the real price, but I don't want to do about 400 of these proportions one at a time. So we're going to use the spreadsheet to accomplish repeated calculations over and over and over in a very efficient and fast way. Let's do a quick reminder about how we set up these proportions to adjust for inflation. For example, if we are trying to adjust into December 2012 dollars, and that's exactly what we're doing in this problem, different proportions that would work would be one option to say, well, the price in 1980 compared to the CPI in 1980 is proportional to the price in 2012 compared to the CPI in 2012. And that unknown is the price in 2012. That's going to be our real adjusted dollars. A different proportion might be, well, the comparison of CPIs from 1980 to 2012 is proportional to a comparison of the prices from 1980 to 2012. So again, down here is our unknown, the price in 2012 dollars. We even have a couple of other arrangements that would work if you were to do the reciprocal of both sides of either of these proportions. But, however you set up your proportion, we should find that they all force us to do the same operations to calculate this unknown amount. What is the price once we adjust into 2012 dollars? All of these proportions would say, if you start with the price in 1980, there would be two operations: multiplying by the CPI in 2012, and then dividing by the CPI in 1980. So any proportion, if it's arranged correctly, and we know there are a few different ways that could be, they should all lead us to do these calculations. These two operations take any price from the past, multiply it by the current CPI, and divide by the CPI from that point in time in the past. So we're about to go back to the spreadsheet to see how can we set up the calculation of these two operations. Multiply by the current CPI, divide by the old CPI. So let's try it for our first row from January 1980. I'm going to click the box for real price. This is where I want my result to show up. I'll go up to this formula bar or input line, however it's called. We know that all calculations need to start with an equals. And what were those operations that we need to do? Well, we have to first take the price we know is found right here in column D. So I can click right here and say, first go back to column D, and we're in row 10, so I see that D10 has showed up. I can click on that box, or I can actually type in D10. What were those two operations? We have to multiply by the current CPI, so times, where will we find the current CPI? Well, it's all the way at the bottom of this CPI column. December 2012, right there. This is in cell F405. So we've taken the old price from January 1980, multiplied it by the December 2012 CPI, and now we have to divide by the January 1980 CPI, which we will find right here in F10. So we see a result that, adjusted for inflation, that price of 1 pound of lemons is just a hair above $2. For now, I'm going to keep all these extra decimal places. Later on, we can talk about formatting these cells so that they appear more like prices. So just a quick recap of what we've done. We did the proportion to adjust a price for inflation. We knew the proportion that we had to set up and what calculations we would need to do. So now we can go over to the spreadsheet and input these calculations. The key for setting up an efficient formula is to not type in the actual numbers that we want to use, but to type in these cell locations that we want to use. So when I wanted to say start with the nominal price, I wanted to actually click D10, not try to type in the number that I see in there, 0.679. And those two operations for multiply by the December 2012 CPI, I found the cell where it was, F405. And to divide by the January 1980 CPI, I found the cell where it is, in F10. So divide by F10. Now that our formula is in there, using as many cell references as we could, we're going to extend this formula all the way down the column. There are two ways that we could do it. We could highlight some cells where we want it to be filled in, and then there is a function called fill. You can find it under the Edit menu, Edit, Fill, and I want it to fill down. Now it appears that this did not work successfully, but I knew this was going to happen. I wanted to illustrate a point. I knew it was going to happen. When we do this fill down, and the other way that we could do it would be to click the place where we typed in our formula and move your cursor to the little black box in the corner and drag it down. That's a different way to do the fill. And you see I still get those zeros. Well, look at what it does when we do the drag down. We entered this formula in row 10, and when it goes down one row, our formula is going to advance all of these cell references. So this formula, where the result is going to be in row 10, is a formula using D10 and F10 and F405. So when I go to the next one, it's going to be using D11 and F11, but it advanced the 406, which was my December 12 CPI, all the way at the bottom. So is there a way for us to say, advance the D11 and the F11, because that's our different nominal price and different CPI, but I want you to always go back to F405 for the current CPI, and there is a way to do that. I'll go back to this original formula, and the cell that we want it to always be F405, what we have to do is, in front of the column letter, put the $sign, Shift 4, and in front of the number, the row, another $sign. Those $signs say, when you do your multiply, always go into column F and always go to cell 405. Never change that. So we get the same result. It hasn't changed our number in this first row, but now when we go to drag down, get your cursor right on that corner square until it changes into a plus, and now click and hold and drag it down. I'm going to drag it all the way down to the bottom. And I'll let go of the mouse button. So you can see that as we click on different cells, that it has advanced. So in row 394, we took cell D394, which is right here, the nominal price. This was January 2012. We can see also that it multiplied by F405, so it stuck with the 2012 December CPI, and then divided by F394, which would be the January 2012 CPI. So it's preserving this proportion of taking the nominal price and the CPI from whichever year we're working, and the CPI from December 2012, because we are adjusting all of our dollars into December 2012 dollars.